All right. If you are watching and in the Slack channel, can you see this? Might be a little delay. Yes. All right. Hooray. Welcome to Remote Ruby. This is our first meetup. So my name is Jason. I'm in Memphis, and joining us tonight is my buddy Chris from St. Louis. Chris is the founder of a site called GoRails, which is a Rails and Ruby tutorial site, somewhat of the unofficial successor to Railscast. So if you're watching this on YouTube and you want to get involved in chat, we have a Slack channel at remoteruby.net, and you can hop in there. If you have any questions, we're going to do a little bit of a Q&A afterwards with Chris, and you can just drop those in the Slack channel, and I'll watch those throughout the presentation, and then we'll field some of those to Chris afterwards. So with that said, I don't think there's anything else, and we'll field the floor to Chris.
Cool. Let me get my screen up here. Can you see that? Let's see. Not working? All right. So tonight I'm going to be talking about a website I built called hatchbox.io. As Jason mentioned, I also run GoRails.com, which is a weekly screencast about Ruby and Rails stuff. And one of the things that I built over the past year is hatchbox.io, which is a hosting platform for your Ruby apps. And I thought it'd be fun to talk about all the little nuances and things that you run into building a hosting platform with Ruby. So when you're deploying a Ruby application, you have a bunch of requirements, but there's mainly three primary things you have to think about. One is you need Ruby, of course. You're probably going to want a version manager on the servers, and that is going to allow you to set up, the newest version of Ruby, or if you have an older app you want to deploy, you can deploy the older versions. You're going to need Bundler with that so that whatever application you have in general, any application these days is going to use Bundler to install those dependencies. So you're not only going to need to install Ruby, but you'll also need to install Bundler for every single Ruby version that you install. Then you're going to need a web server. And for Hatchbox, I went with Nginx and Passenger. And one of the reasons for that is because Nginx is super fast, but instead of having to deal with whether or not the applications use Thin or Unicorn or Puma or Webrick, I can go and just have all of those ignore that and use Passenger out of the box. So I don't have to build any unique things for each one of those, which is really nice. And Passenger is extremely fast and easy to manage. So that's one of the big benefits of that. There's a lot of simplicity there, but Passenger also supports Python and Node applications as well. So in the future, I can potentially support those as well. Lastly, we have to support, of course, our databases for our web apps. Generally, I've supported Postgres up until just about a couple weeks ago. That's kind of, I encourage people to use Postgres, but plenty of people like using MySQL. So I rolled out MySQL support recently, and every application these days, whether you're using Redis for Action Cable or for Sidekick or even just caching, we all tend to have a need for Redis somewhere in the stack. So every application also gets a Redis instance out of the box. So there's quite a few moving pieces here, as well as all the dependencies to get those things installed. You have to get your different packages and their repositories set up, and you want to include some things like firewalls as well, which are kind of the complexities of getting all of this set up. So some of the alternatives out there are, of course, Heroku. This one's definitely like where everybody starts. It's the easiest. You just change a few little things in your code to make them Heroku compatible. Like we all had the Rails 12-factor gem in. And then that gives you really, really easy support to get your application deployed. You don't have to know anything about deploying an app or dependencies or Linux, any of that stuff, and it's really easy. The downside is that the second you want to go into storing tons of data in your application or adding Elasticsearch or whatever, you end up spending quite a bit of money pretty quickly. So that's one of the reasons why I wanted to build Hatchbox, because Hatchbox works on your own servers. So you can do any provider that you want. You can use Linode, DigitalOcean, so on. You pick the server wherever is most convenient and cheapest for you. And then I will try to give you as best of a Heroku-like experience as I can. So one of the other alternatives is using something like Capistrano to set up your deployment process on your own servers. And this is one of the things I explored using as a foundation for Hatchbox. But it's another one of those things that is now a dependency. And so I have to manage versions and all of that stuff. And Capistrano is out of my control where they take it. So I've chosen not to go with any sort of Capistrano stuff. But I've worked on making Hatchbox very similar to that so that the workflows and deployment process are very easy to get used to if you've ever used Capistrano, but you want to just save some time deploying to your own servers. Using Hatchbox, you can do that, and you're going to run into a lot less troubles than you would managing it yourself. So to get started building your own hosting platform, you have to connect with several different providers. So you want to make it easy to create a new server. And I currently support DigitalOcean, Vultr, Linode, and Amazon Web Services like EC2 or Lightsail. And those and any other service actually will work. But there's a few of these that I've done, like DigitalOcean, Linode, and Vultr, that you can directly create new servers from inside Hatchbox with. So one of the benefits of that is it's really convenient, but I didn't want to limit this to just those services. So there's an option for you to connect via SSH. So you can create a server on Amazon or wherever your local provider is that's the cheapest, and just set up the connection to Hatchbox manually. So these ones that I've integrated, they are really smooth, and you can buy a new server inside Hatchbox, which is cool. But there's also the ability for you to go buy a server somewhere else and just connect it to your local server at home if you wanted to do that even. So to do this, we really need to build out a interface in Ruby that kind of makes all of these work the same. Their APIs are all very different, and the workflows tend to be different for them. And so to build out these easily in the future, I needed to define a standard interface to make that really easy to add new ones. And the same thing goes with your Git providers. So when you have your code hosted somewhere, we need to be able to check it out on the server. And we need to have SSH keys to access that. So every server gets its own SSH keys for deployments, and then you add it to your Bitbucket, your GitHub, or your GitLab accounts. And then that server can go and check out the code from that repository. And we want to do the same thing as well for these. So if you happen to have a private GitLab instance, or you're just running your own Git server that you did from scratch or something, I want to support that as well. So we have another thing here that really pushes the code to try to have some sort of similar interface across all of them so that we don't have to worry too much about the details of how each one of these APIs works. And the UI that it looks like, or that we currently have to go and build a new server, looks like this. You choose your hosting provider. And then once you do that, we allow you to choose the size and the region. And because the pricing works out so that you can click on certain ones and they may not be available in certain regions, all of this is dynamic and hits their APIs to go and pull that information in real time. So that's one of those things that needs to be standardized across all of these. And so what I've built is for the hosting providers, we have a common interface that looks like this. We have a base class where we have all of the methods that we need those clients to implement. And so here we set up the client inside of the initialize method, and then all of the ones that we use to grab the sizes and the regions, we'll go and implement those with the appropriate API library. But the base class will raise a not implemented error, so we can make sure that you actually implemented those methods. It will throw an exception if you happen to have forgotten one. And that way you can know for sure which ones you've finished and which ones you haven't. Then down below, we have some actions like adding an SSH key, creating a server, and there's a couple others here that I didn't mention, which is syncing the status of the server. So we need to know when we create the server, it takes at least a minute to go and boot up a new server. So we need to have a time of, when we need to kind of guess when that's going to be finished. So we want to poll a few times and say, hey, is the server ready or not? So we have a sync method for that as well, so that we can go and say, hey, is it done yet? No? Okay, let's check back in 30 seconds. Is it done yet? And when we find out that it's ready, we have another method there that checks the status to say, is it okay? Is it ready? Or whatever the VPS provider gives us. So here's an example of the DigitalOcean one, a few methods that I've implemented on it. In DigitalOcean specifically, they have the ability for you to look up SSH keys on your account by your fingerprint. Now, this is different than all the other ones. And so in this situation, we want to just check and see if your server's SSH key is there. If it is not, we want to go add it. So we rescue from that error, and we go ahead and add it to your account. And then we go and create the server. And that server, part of the options, we pass in that SSH key based upon the fingerprint. And so that allows us to go ahead and easily set that up so that we have the SSH key available as soon as the droplet is ready to go. And then we can SSH in and start installing all those packages and dependencies that we need to do later on. Here's an example of the sync and finish provisioning methods. These are really straightforward. We're just checking to see if we can find the droplet. If it exists, then we want to update our copy of its details in our database so we know what status it is and so on. And in this case, our finished provisioning is looking for the active status. Other services may be like okay or ready or running or something like that. So in each case, whether it's DigitalOcean or Vultr or Linode, we're going to have custom versions for each one of these because they're going to be a little bit different on each time. And so then in our background workers, when you click to create a new server, we go and spin up a background worker that calls these methods to create the new server. Then we do a little bit of polling and wait until it's active. And then we kick off another job to SSH in and start installing your packages. So this piece here that grabs the size and the region is really kind of nifty. I refactored this recently. And so it's just this really simple show action that when you choose whether you picked DigitalOcean up here at the top or Linode or Vultr, that will go kick off a JavaScript request to grab the JSON for the size and the regions, which hits this action and it gives us some JSON back. And each one of those is set up so that we can cache it for the provider. So whether it's DigitalOcean or not, we will keep a separate cache for each one of those. And then it uses constantize to go find that correct hosting class in order to call the size method on it. So it's pretty neat. It will go and use that in order to really quickly go and look up the correct class. And that is one of the nice things that allows me to go and define a new hosting provider really easily. So I can have a button that I add and a class that I add, and this code here for the sizes and regions will never ever have to change because it will work exactly the same as the other ones as long as the sizes method returns the correct JSON format that the client will be able to parse. So that's nice because it allows us to add in those new providers without having to do any work on some of these other features that are tangentially related. So this brings us to running commands on the servers. Now this one is the bulk of the application. So this is what I do for provisioning a server. We install a bunch of packages, we configure your firewall, we install your databases, and turn on Sidekick and deploy your code, restart Sidekick, restart your application when it's finished deploying. All that stuff happens by us running commands on your server. So that looks like this. We have Sidekick jobs that run what I call scripts, and we have actions, which are basically logs of those scripts running. So this is pretty straightforward how those work. But we have scripts that do a bunch of different things. And so each script has a common interface as well, where you can upload files, you can run commands, and you can do a combination of the two where you can upload a file and execute it. And these scripts also have a standard set of methods around them too, to catch things like a long-running command or something that ran and ran and ran, and it was maybe waiting for the user to type yes or no. That's a common problem that you can have that hangs your script. And so we want to be able to add timeouts in there so that if we catch a script running for more than 5 minutes, we can kill it and fail that action that we were running. Same thing goes with missing servers. You might have someone that deleted the server, but Hatchbox thinks it still exists and it tries to connect and it just times out or something. We also have command failures. So sometimes maybe a version of a package changes and something breaks. We want to be able to catch whenever your commands fail. And last but not least, this is one of the more fun pieces of the application, is we want to be able to run those commands and relay the logs to the browser in real time. So I'm using Action Cable for that. And our Sidekick jobs are taking those SSH commands and taking the output of that and then piping it through Action Cable to your browser so you can see it update in real time. And you know that it's actually working and it's not just stalled or broken. And that was one thing I didn't have for a long time, where your application would actually have failed. And on the front end, you just see a spinning wheel and you have no idea if it's working or not. And that felt really painful to look at. So the relay of logs to the browser in real time is like a crucial feature for users to feel good about the application. So these have a similar standard interface that I've got. I've got a base class. It implements an on method here, and this one is pretty straightforward. It just creates an SSH connection to your server, and it starts by logging it updates your server status to the processing state, records that, and then it begins to execute the block that you would pass in. So if you wanted to build your own script, you would call this on method, you pass in the server, and you tell it which user you want to log in as. And then you would do a block in your Ruby code, and then you would tell it what you wanted to do. So this will automatically handle things for us, like our common errors of authentication failures, connection refused, connection reset, connection timeout, and host key mismatch, which is, you can imagine that, say someone boots up a server and they delete it, and then you try and connect to that server, but the IP address has been assigned to someone else's server, then you will get like the host key mismatch error there sometimes as well. So we have all of these in this base class so that every implementation of a script that we write from now on will automatically have these pieces of safeguards in them. So we have this to be our central place that we can update anytime we need to add new errors that we detect that are common or something, we can add all that in here, and then all of our code becomes more robust because of that. And it's a central place that we can update those things. So here are the methods for uploading and executing and uploading and executing commands. So the top one is just a combination of the two at the bottom. We use the net SSH library that's built into Ruby, or it's one of the common packages at least. And that we use the SEP library to upload a file. And then you can just tell it what file name you want it to be on the server, and you can upload a file object. I'm using string IO there at the bottom, so we can use strings instead of files to upload. And then being able to execute commands is pretty straightforward. You just give it the command. But we have a custom method here inside execute called ssh.execSC, which we'll touch on in a little bit. This is a method that is used for gathering a bunch of extra things that the SSH library doesn't really give you, just in a nice format. So you can build this method so that you can grab the exit codes of commands on the server, so you know if they have failed or not. And you can also do things like every packet of data that you receive of output, you can take that and then pipe it over to action cable. And then the top one is just straightforward. I have a common way of uploading scripts and executing them, and we have a few options there. So we execute it with bash, we pass in some arguments optionally, and then we tee the output to log files on your server and to the SSH connection, so I can save it inside Hatchbox, so you can see those errors and things and do debugging in the app itself. So we keep a copy of those on the server just in case you want to SSH in and look at what's going on. But this is just a nice way for us to keep that all in sync for every script so that they work all the same way. Then one example of a script is grabbing your Rails logs. So I have a tab where you can click on it, and it will immediately fire off a Sidekick job that runs this script, which simply says, we don't want to log this action into the actions table, and we're going to grab 300 lines of your Rails logs. And so this goes in on server as the deploy user. We start an SSH connection, and then we run SSH exec, which is the command that you would just run on the server if you were already in the right, if you're already connected. We save the output of that to logs, and then we broadcast that over to the app. And so then our client side just receives that broadcast too, and then renders it out on the page. And so that way we can get you the Rails logs just like that. And it's only 2 lines of code for me to go grab those from your server and then send them over to you in the browser. So it's pretty neat that you can write these scripts that short and make a function like that so that you can check out your Rails logs in the browser. It's that simple. Here's another one. We have the ability for you to write your own scripts. So these are user scripts. And these we definitely want to make sure that we time out if they were run for more than 5 minutes, because you might put an infinite loop in there, and that would steal one of my Sidekick workers forever until I restarted it. So this, we allow you to choose which user you want to log in as. So you could log in as root or deploy, and we will upload and execute that script that you gave us. And the content of your script is script.body. So script is a model, and we just pass that in, and then we set the timeout of 5 minutes around it. And then all the other things like authentication errors or any of that stuff is handled by our base class. And so none of these scripts really have to worry about any of that unless they are specific to the script. So I can create new scripts to add all kinds of features to the application in like 5 minutes because we have this really nice interface to work with. For streaming those logs back to Action Cable, we created a new method on net SSH Connection Session. That's the class that net SSH uses when you're connecting to the server over SSH. This method has a callback so that you can get every block of data that it receives. So every little chunk of the output, it packages up into a blob, sends you that back, and then you can send that over with the action cable, and then just continue appending that to your log output. And so this is sometimes you will see when it's printing out a lot of logs all at once, you'll see like chunks of them show up on the page. And that's because the net SSH stuff grabs a certain, buffer size and gives that back over to us, and we forward that over with action cable. This method, though we added which I'll show you in a minute, it actually grabs the exit codes of the commands we rerun as well. And that's a crucial piece here, because if any of our commands fail, we want to know that, and we want to be able to tell you that it failed, so that you can do debugging and figure out what went wrong. It's kind of a crucial thing, but as I found out, the net SSH library didn't have a great way of accessing that immediately. And this, I found, this is not the complete thing. I stripped out a few bits here to make this fit on one slide. But if you're interested in this, I found this method, similar version of this on Stack Overflow. And you can take a look at this as well, and I can send it to you. But basically, this sets up it adds another method in there so that it creates a new channel, which opens the SSH connection, and then we have some callbacks. It executes the command. It has some more callbacks. When the channel has data, we can add that to the standard output data. So we're keeping a set of the entire standard output in the string, so we can return that to you at the very end. But also I have script.concat log in there, which is used for sending that over to action cable. So I send the chunk of data over to the script. The script knows which app or which server it's running on, and so it knows which action cable channel over there inside of the script to send it to. Then in the middle there, we have channel on request exit status. That's our exit code. And so we can grab that at the very end and then save that to a variable. And then down below, we can check and see if that exit code was not 0. And in Bash, exit code 0 means it was successful. Any other number is an error. So we can actually raise an error inside of this class called command failed if it doesn't fit the Bash same structure. So that allows us to then build sort of the same fallback safeguards in here as we would have in Bash itself directly. So that's kind of nice to have. And then streaming our logs, we have a server channel. We also have an app channel. So whenever you connect to the website, we start streaming for every server. There's ability to collaborate. So if I don't own the server, we can also stream for servers that you're connected to. I don't have that snippet of code in here, but if you're a collaborator on a server, we can connect you on the same stream so that you will see the logs in real time in your browser as well as the owner, and that we're both using action cable for on the same stream. Then one really good thing that Heroku did that I just recently added was the ability for you to define dynamic Ruby versions. Originally, I had it set up so that you would just choose your Ruby version ahead of time when you set up the server, and it would go and install those, and you would just know that they were installed correctly. But that's inconvenient if you ever want to change the Ruby version of your application. So what I've done is I've removed that functionality and now made it so that when you deploy, part of the deploy process checks your .ruby version file. And if it finds that file exists and it has a valid Ruby version, then it will go and install that Ruby version if it is not installed. And otherwise, it will just use that version to process your app. If it's already installed, it doesn't do anything. Then, if there is no Ruby version file, we check your gemfile.lock. And that's really just because it's easier to parse the gemfile.lock instead of your gem file. So if you, like on Heroku, they recommend that you put your Ruby version in your gem file. You have to run bundler, so it updates your gem file.lock, and it's also written out inside the lock file. So I look there, and then that makes the Ruby version in your gem file.lock the secondary one if we didn't have the first one. And then lastly, if neither one of those were present, we'll just default and install the latest version of Ruby, or whatever the most stable version of Ruby is, because if we upgrade too soon to making, say, 2.5.0 the default, there will be a lot of people that haven't updated their devise gem or whatever else is breaking, and those will be a problem on all new applications. So I'm a little slow to update the default until it's actually pretty stable and most people have upgraded. So the dynamic Ruby versions mean that you can just go define any one of those and then change it. And so if you've previously deployed 2.4.3, then it will be installed. But if you change it and you deploy your application again with 2.5.0 in the file, then it will automatically install that version next time around. So it's kind of nice to have that automatically done for you. Same thing kind of goes with supporting multiple frameworks. I want to do more of this, but I've just recently started doing non-Rails stuff. And for the most part, these are just different commands that you would run when you detect the different frameworks that might be in there. And so for Rails, you want to do assets precompile and maybe DB migrate. Hanami has different commands for the same things, and Padrino as well, and Sinatra. They depends on what ORM those are using or how your assets are set up. So we want to make that customizable for anything, and not just be super Rails specific. So every application comes with a default deploy script, and it runs bundle install by default, and you're free to update this. So this is the default bash script that I wrote to deploy Rails, but I've also gone and added some stuff in here to check and see if, hey, do you have Hanami? Then if you do, we can run Hanami assets precompile and Hanami DB migrate. And so this way we can add in support for other frameworks. And then if you ever want to customize this, you are free to do it to your heart's content. So it's really nice that you're able to do sort of any deployment process that you could ever want. That was one of the features that was really nice about Capistrano. But you don't really get that in Heroku. So this is one of the benefits, that by default, it's going to migrate your database. And so the first time you deploy your app, you're not going to get a 500 error if you forgot to run DB migrate, like we've probably all done on Heroku. So this is pretty cool, and it is very flexible, and you can go and add other things in here. Like at the bottom, I've got cron tab support. So if you want to add cron jobs, you can use the whenever gem, define your config schedule.rb file, and then this will just go ahead and update your cron tab using the exact same name every time. And so it will update your cron jobs accordingly. So you are free to manage those, and it doesn't matter what framework you're using. It just checks to see if that file exists, and it will go ahead and do that for you. One of the last things is environment variables. This is one of those things that is kind of hard to manage if you're setting up your machine yourself. And finding a good place to define your environment variables that are loaded all the time consistently can be tough. And so people use .env and other gems to manage this. But what I've done is use the RBN vars plugin. And so we write a file inside your apps folder called .rbn vars. We put all your environment variables in there. And that allows us to have RBN on your server, which we use for the version manager. RBN will automatically check for that file. It will set those variables for you. And then that is all done before your Ruby application boots, which is really nice, because that means you can deploy multiple apps to your same server using database URL in both of those, where if you had a single file that defined all your environment variables, you would override the database URL with your second definition. So having these separate files allows us to have environment variables with duplicate names just work automatically out of the box. So this is great, and RBN was one of the choices that I used because I'm really familiar with it. It has this plugin, and things like RVM or RVM actually are kind of heavy on their bash integrations, and so it's a little bit harder to make that consistently work with your Nginx installer passenger, whereas RVM just gives you a shims file that you point to, and everything is taken care of from there. Then last but not least, one of the really nice features of deploying 2 apps to one server or multiple apps to one server is that I generate a subdomain for hatchboxapp.com. So if you have ever deployed to your own server, normally you just have access to the IP address before you've set up any domains. And you can't access both apps because only one is going to be responded to on the IP address. So out of the box, any new app that you deploy gets a generated subdomain for hatchboxapp.com. I hit the API for, I believe I'm using Cloudflare, and it adds the subdomain, points it to your IP address, and then you can access all of the apps on your one server by using those subdomains. And this is why Heroku does the generated domains. You have to give it a name, and it puts that in the subdomain. That's the reason why they do that, so that they can have multiple apps accessible on the same server there. And so they set that up, but you have to define the name. I just generate you a really short subdomain here because I don't force you to give your apps a name like that. And then we have SSL support. This one is pretty straightforward. I have scripts for this where basically you give me your certificate chain and your key file, and then the script just goes and puts them in a specific folder with the right names, and then configures your Nginx file to use those with SSL. And Let's Encrypt is also another very straightforward. It's a little bit more complex than the other one, though. It actually, Let's Encrypt will make you set up and verify your domain on port 80 first before they will give you a cert. So you have to change Nginx temporarily to go do that. And then you have to set up your official SSL support once you get the certificate on your server. And then you also need to keep that port 80 thing open so that they can renew it 3 months down the line. So this script just goes and does that process, updates your Nginx a couple times, runs the commands for Let's Encrypt, and then it also installs a cron job so that every week it attempts to refresh your Let's Encrypt certificates for you so that your SSL never expires and is always up to date. So that is it. If you guys have any questions or whatever, I am happy to answer them. I know that there is a whole lot that I covered there. This application is, kind of like building your own Heroku, so it's not the simplest as you might imagine. So that is it.
Cool. We had no questions come through during, so now if there are any questions, is a good time to ask. And while we were waiting, I will go ahead and point out housekeeping things. I will keep this channel open for about a week. If conversation is still going, then I will let it keep going. If conversation starts to die out, we'll close this one out. And then right before next month's meetup, we'll open up a new channel just to kind of keep it siloed. So it looks like we have questions coming in, and I will let Chris get to that.
Sure. Daniel Draper asks, was there a reason for not adopting the bin setup file or considering a new file such as bin deploy for the deploy script management? Really, I don't want to ever, generally the bin setup and bin deploy stuff is like things you would write in your own repository. So I don't have any control over what you put in your repository. So I need a totally separate deploy process in my application, and something that's generic. So I would typically, if you were to build this yourself, custom for your own servers, that would probably be the way you would want to do it. Or with Capistrano, same thing. And you could use, Ansible or Chef. And one of the reasons why I didn't use any of those, and all of this is set up directly with Bash scripts, is that this is a very complicated thing, and there's a lot of things that can go wrong. So I don't ever want dependencies of mine that I picked, like Capistrano or Ansible or Chef, to break on me or to change or something where I can't go fix them because I don't know them well enough. And so this, I know 100% of what I've written. So anything that goes wrong, I immediately know where to go find the problem and then how to go fix it. And it reduces the chances of like Capistrano deciding that it's going to function differently tomorrow and I can't, or I don't agree with that or don't want to use that. Then everything is up to me, and I can design it however I want. And that's kind of the benefit of using as few dependencies as possible for this whole process. Favorite tech book? It's a good question. I haven't really read too many programming books, to be honest. The last one that I remember that I really loved was Metaprogramming Ruby. That was the book that was like, just like opened my mind on Ruby when I was learning it. And it was like, wow, like there's a lot of magic going on here, but it's all purposeful. Whereas I was coming from Python, and Python's very explicit about everything. And I was kind of getting frustrated with Ruby because there's, a lot of implicit magic going on. And that book was like, yeah, there is, but guess what? It's all designed, with good intentions, and it's going to save you a ton of time because you don't have to be explicit about every little thing. And that book was really good for explaining, how Active Record works and generating methods for you and all that stuff, which I really loved. I have not considered using, Glenn asked about supporting Heroku build packs. I have not considered that, just because I was also like going for simplicity as much as possible. Heroku build packs are great, but they're kind of like designed for containers, and Heroku, you can deploy Docker containers and all of that stuff. I'm literally going for as simple as possible. Like, you create a brand new Rails app, you click a button to set up a server, you click another button to deploy your app, and it should work. And you should never have to think about containers or any of that stuff. That's my goal. And this is kind of different than theirs, where they want to support literally everything under the sun. So containers are perfect for that. I'm going for optimizing, the convenience aspect of things and going for as simple as possible of a deployment process, basically. And so that would kind of be, outside the realm of where I was wanting to go. Yep, that's the Metaprogramming Ruby book from Prog. Really recommend that one. What's next for me? One of the things that Hatchbox doesn't support yet is like a cluster. So if you want a load balancer and 3 or 4 front-end servers and a separate database server, it doesn't support that just yet. But that's one of the things that's already pretty modular in the way that it works right now with the background jobs and the scripts. So I really would just say, okay, well, if you have this cluster, then the load balancer runs this script, the app servers run these scripts, database server runs those. And so that's one of the next features that I want to add for it. But I'm also working on, because I've been doing video so much, I'm working on another app, which still kind of, if you use support in Hatchbox, you'll see this thing maybe called AirCheck that is a customer support tool I'm working on that I want to use video with and kind of encourage more support to happen via video because it's so much friendlier. So that is a project that I'll be like officially announcing later on this year, but I'm kind of exploring the concept of where can we use video more in our lives and make better connections with people remotely, because we're going to have a lot more remote jobs. And if we don't talk to each other over video, it just isn't as human anymore. So that's one of the things that is high on my list for all of that going forward. How do you handle server infrastructure updates, security patches? So the easy thing for that is I actually, part of the setup process, have apt on Ubuntu go ahead and turn on automatic security updates. So it will automatically install any security updates that come through the package system. And I believe that runs once a week or something like that. And that takes care of the majority of things. We have a firewall that's set up so that only SSH and port 80 and port 443 SSL will be allowed. So then that protects your server quite well. We also disable password authentication for SSH. And I even lock you out of your own server at first. So you have to add your SSH key in through Hatchbox because the Hatchbox SSH key that it's internal is the only one that has access by default. So we try and keep it, as automated for the security updates as possible, but it's also your server. So I'm not trying to fully manage this and all the security updates like Heroku does, because that's part of the reason why you pay for Heroku, and they manage the server entirely for you. And there's a little bit of this that's still under your control and kind of your job to make sure that you keep an eye on any packages that are needing updates or whatever. But by default, I try and give you a good set of configurations to take care of that.
So still a couple more typing. We'll wait just a minute.
Yep.
I'm going to add a link to Hatchbox in the video. Yeah, but I didn't know how to link it because its name is hatchbox.io.
Any plans to add monitoring of application and or host? Yes, actually, that is one of the things I would definitely like to do. Kind of, like a pingdom type of thing, just to make sure that you get a 200 response from the website and then alert you. That may be something I'll build. Also, I want to do kind of, excuse me. I kind of want to do monitoring of like memory and CPU usage and that sort of thing, because when you're deploying multiple apps to the single server, you can run out of RAM pretty easily. And so then your future deployments can fail because you've run out of RAM because you've deployed to, say, a 1 gig box, and then your app is running, taking up most of the RAM. And when you do your next deployment, it only has a chunk left to pre-compile your assets or install Nokugiri or something. And then that needs like all your RAM. And so then it can die a few times. So I kind of want to have some memory monitoring so I can like warn you and say, hey, you might want to consider upgrading to the next size of RAM. Yeah, it's unintended upgrades is what I set up for those security patches and stuff. Yeah, what's Brandon D's asked, what's recommended for when we need to mix Rails apps with other kinds of tech stacks in the same environment? Well, because this just really cares about the Rails aspect of things, and I install Nginx for you, you are free to install like Laravel apps or Python apps or anything else you want on the server. It is your server. I'm just helping you basically like keep it up to date and have a working Rails version on there and easy deployment. So the intention is that it's still your servers. You can install Elasticsearch on there. You can do whatever you want, and you have that freedom. And so if you wanted to deploy other apps like WordPress or something, the way that I would do it is you can either use the scripts functionality in Hatchbox to install PHP if you wanted, or you can just SSH into the server, install PHP, and then use it like it was your own machine. So these are all things you own. Then when you want to set up the website, you can go to the Etsy Nginx sites enabled folder and then add your new Nginx config for your WordPress app or your Laravel app. And then you can have that running on your server as well.
Cool.
All righty.
Well, I think that's it. So cool. All right. Well, feel free to hang out in the chat. All the virtual claps in the world for Chris for doing this.
Thank you guys for having me. If you have any questions, of course, you can tweet them at me or email me, chris@gorails.com. Check out my screencast if you are into that. But yeah, thanks for having me.
Cool. And we will do this again hopefully next month. We will I'll announce the presentation as soon as I get it lined up. So, and a date and all that. So thanks for joining us. And
do you have a way of if someone's interested in being a presenter, reaching out to you? Or
yeah, there's actually a link on remoteruby.net. It's buried in the presentations each month. There's a link and it's a Google form that comes to me. So
cool. All right.
We have a couple people interested right now, and so we'll start lining them up.
Cool.
Awesome. Well, thanks so much, everybody, and I hope to see you next month.
All right. Thanks, guys.